So myself, I'm Dr. A. Mahaboob Basha. Today I'm going to talk about a simple concept. That's what we call the chi-square test. Chi-square test for two samples. Uh, Basically, it is used for to test the association between two variables, to test the relationship between two variables. We will use the concept of chi-square test. Chi-square test basically it is a non-parametric test where we will use the chi-square test for categorical data or nominal data or ordinal data type of data types. We will try to use this chi-square test for two samples. So here I'm going to explain directly with a questionnaire. So here I have two different types of categorical variables, gender and brand. Gender, it is male and female. Brand, it is having four different types of brands. Suppose Sony, Samsung, Apple, OnePlus. So brand, it's a categorical variable. Gender, it is also a categorical variable, male and female. So here I'm having totally 300 respondents. Here totally I'm having 300 respondents. So now today I will show you how to perform chi-square test for two samples using MS Excel. So two categorical variables, gender and brand. Brand it is having four types, Sony, Samsung, Apple, OnePlus. Gender it is having male and female. So when you take this, suppose, so how to perform this in essence? First of all, you need to select the whole data and go to insert and click on pivot table. Here it will ask you where you want to keep your output, whether you want to keep an output in a new worksheet or you want to keep in existing worksheet. New existing worksheet where I want to keep my output is here. I want to keep and click OK. So it will show you like this. So now what you have to do is here gender that I'm trying to show on rows and brand that I'm showing to show on columns, and the summation sigma value should happen through brand, and still it is not it is not multiplied by the things, and sum of brands. When you click here, the value field settings, and here take the count and click OK. And now this is the contingency matrix. So here actually we need to develop a contingency matrix, a contingency table, and so likewise. So if you go here, your observed frequency table will look like this after all makeups. And what you need to do is you need to create an expected frequencies. So how to calculate expected frequencies in the sense this is equal to this, and row total, and freeze it, click F4 and multiply with the column, close the bracket, and take the total sum and freeze it. Again press F4 so that it will be freezed, and press enter. So it will be calculated like this. Now here is also take this, open the bracket and take 180 and press F4, freeze it, and multiply this with column sum and close the bracket, and divide it by the total sum, and again freeze it so that press enter, you'll get the values like this, and take the row sum also so that the expected frequencies will be calculated like this. So now what exactly the formula of chi-square test? Chi-square equal to sigma equal to 1 to n observed frequency oi minus ei whole square by ei. So oi minus ei whole square. Now how to put whole square in the sense oi minus ei cap, shift plus F6 shift plus F6. If you press, you will get cap value. Otherwise, no square calculation, it's a bit tougher. So how you can able to calculate the cap in the sense, suppose I will show you. So, uh, you know, capital O minus capital E and cap shift plus 6. If you press, you will get 2, and then automatically we can able to calculate everything. So y minus ei whole square by ei. So what I required is y required ei required y minus ei whole y minus ei required y minus ei whole square required y minus ei whole square by e required, right? So it's very simple to calculate all these things. And if you sum up all these values, the chi-square value 0.9994 will come. Now still it's not sufficient to calculate the chi-square. So you require significant value, the degree of freedom, critical value, p-value, the significant value at 5% level of significant 0.05, the degree of freedom, the row minus 1 into column minus 1. So you can take 2 minus 1 into 4 minus 1. And the critical value at 5% level of significant at 3 degrees of freedom. What is the value in the sense? 7.81 at 5% level of significant 3 degrees of freedom, the value is 7.81. Then we can able to cross check whether it is right or wrong. If you double click it, the chi-square INV, the probability 0.05 and the degrees of freedom 3. And if you close the bracket, if you press enter, what you will get is 7.81. Yes, even you can calculate from this particular formula CHIINV of, right? And how to calculate how to calculate the p-value in the sense CHI test of, you know. So D6 to G7, this is the internal data. So this is the internal data, right? So this is all about right. And now D13 to G14, this is all about this particular data. So if you calculate this is, you will get the value here. So it's very simple. So here D6 to G7 from this particular part, and D13 to G14 this particular part. So this particular part, and press enter, you will get 0.81. And even you can cross check this is whether the chi-square value it is correct or not. Chi-square that INV, right? And this time the probability value, take p value this one and comma at 3 degrees of freedom this is, and press enter, you will get the same value. So you can cross check like this. And so here now I'm going for my hypothesis. There is no association between gender and a smartphone brand preference. Alternative hypothesis H1, there is an association between gender and the smartphone brand preferences. So after that we can able to calculate hypothesis calculation. Basically it is two types: critical value approach, p value approach. Critical value 7.81, p value 0.801, chi-square value 0.994, significant value at 5% level of significance. So the critical value, the test between critical value and the chi-square value, critical value is greater than chi-square. Critical value is greater than chi-square calculated value except null hypothesis. Critical value 7.81 greater than calculated chi-square value 0.994. So we accept the null hypothesis. So that means that what's happened here, there is no association between, gender and smartphone brand preferences. So that's how we can able to calculate. That's how we can able to calculate